Making measurements is never my most favorite topic of the year, but it is necessary. It's something that unfortunately too many students take for granted, and then they'll end up losing careless points on lab reports for not making proper measurements. When we make measurements in the lab, we need to look at the measuring tool or device that we're using. We make the measurement as precise as possible, depending on the markings of the graduated cylinder or ruler or whatever we might be using, plus one estimated decimal spot. And that's usually where people will go wrong. They'll forget to make that estimate, and that is part of the measurement. That's giving us as much detail as we can possibly provide. These are all considered the significant figures, the significant parts of a measurement. All of the measured numbers that we can get off the measuring tool plus the one estimate. So, for example, if I see students that might have data like this, I know that they must have all used the same measuring tool. They were all measuring approximately 20.1 milliliters, and the last spot is an estimate. And you'll never get that estimate marked wrong as long as you take the estimate. This tells me that for sure they knew that the volume hit the 20.1 milliliter mark. The last spot tells me that, okay, it was a little bit higher, and it ranges from maybe like about 20.15, 20.17. That last spot is important, and I promise I won't ever mark it wrong as long as you take that estimate. If you don't, if you just leave it as 20.1, that tells me that you were uncertain about the 0.1. I know for sure it hit 20 milliliters. I'm estimating 20.1. Maybe it was 20.0. Maybe it was 20.2. But that's not the case here. This graduated cylinder must have a line that says 20.1 milliliters. And we know it hits the line, and in fact, our volume reading is a little bit higher. So we definitely need to be familiar with different kinds of measuring tools and how to record the proper amount of decimal spots. So again, we might have data like this, and we're using different kinds of scales. I don't know why it's in pounds. We'll never, ever, ever measure in pounds. We'll only measure using grams. But I've got a bathroom scale and then some kind of an electronic balance. Do these objects have the same mass? It depends on the precision of the measuring tool. If I'm just using this bathroom scale that only measures to 1/10 of a pound, well, then I'd say, yeah, to 1/10 of a pound, yeah, they were both 1.5. But with a more sophisticated measuring tool, like an electronic balance, now I'm going to say no. Now, if I were to round these to the nearest 1/10 of a pound, then yeah, they both round to about 1.5. But I might not want to round my masses in the lab. I want as detailed of a mass as possible. Now, no, they don't have exactly the same mass. Another thing that will cause concern, something like this next question: what is the difference between 25 milliliters and 25.00? This is something that they will pick on you for on the AP test. They will take off a half a point if you don't deal with this 0.00 properly. A lot of times you'll get this data and you have to do some calculations or something like that. And let's say in the problem it was listed as 25.00 milliliters. And then when kids do their calculations, they'll be like, 0.00, who needs that? I mean, 0.00 is like point nothing. So they'll do their calculations saying 25, which they'll get the right numerical answer, but they probably won't record the right amount of sig figs, and they'll probably lose a half point for not using proper sig figs in their work, throughout their work. These numbers are not the same. If somebody just says 25 milliliters, this is the uncertainty, this 25. This is the estimate. This tells me that the person wasn't really sure if it hit 25. It could have been 24. It could have been 26. I don't know. The best marking they had on their graduated cylinder was 20 milliliters. It must really only be marked every 10 milliliters. So their best estimate was to say 25. I don't know, maybe 25. If somebody tells me that the measurement is 25.00, Oh, I like this. That last zero in the tenths, hundredths of a milliliter spot, that's the estimate. So now this time they're saying, oh no, it hits the 25. There is a line for 25. And in fact, there's a line for 25.0, 25.1. And I know for sure it does not hit the 25.1 milliliters. So I'm going to say 25.0. And to be even more specific, I think it's right smack on the line. So my last estimated decimal spot can be a 0. If you think that the measurement is right smack on the line, you still have to take that spot as an estimate, but you can estimate 0. These numbers to a freshman might look the same, but to an AP kid, these should be drastically different measurements. And it's going to give us different precision in our calculations and in our final answer. I want that 0.00. That's important. Other things that we should make note of when we make a measurement. I think most of us have measured using a graduated cylinder. If not, you've fallen through the science cracks. Obviously, we want to measure to the bottom of the meniscus. We want to be at eye level. We want to check the markings on our graduated cylinder. We'll find in the lab that we've got a couple different graduated cylinders, and they are marked differently. So I kind of take a little peek here, and I've got 80 milliliters, 90. This must be marked off every 1 milliliter. So I'd have 80, 81, 82, 83, 84, 85, and so on. I want to measure to that bottom of the meniscus. So I might be able to say, for sure this hits 80 milliliters. For sure 81. For sure 82. That right there must be about 82. Oh man, I don't know about the 83. I think it might be a little bit less. So I know for sure it hits 82 milliliters. And that's the best I can do using the markings on this graduated cylinder. So the last spot is my estimate. I'm going to estimate the tenths. I don't know. Maybe it's a little bit over halfway. Maybe I measure 82 and I'll guess 0.6. I'll estimate 0.6. There's my estimate. And then I would put a unit milliliters. Now, let's say you were working on some homework problem or something like that, and your buddy said, ooh, but I wrote down 82.7. That's fine. As long as you have that proper estimate in the tenths place, and it's reasonable, that's fine. I promise I won't mark your estimate wrong. Another option, one that we should be familiar with, is reading a burette. Burettes kind of look like graduated cylinders, but they are kind of marked differently. We'll use these quite a bit. You're going to love them. Most commonly used for titrating, like acid-base titrations. That's going to be a blast. Burettes measure volume delivered. So the 0 marking is usually way up on the top, and this would be like a 25 milliliter burette. Whereas a graduated cylinder might have like 25 on the top and the 0 marking would be on the bottom. So when you read a burette, you kind of have to think backwards that I have delivered 20 milliliters. This would be the line for 20 milliliters. What do we got here? 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Whoa, this is not only marked off every 1 milliliter, but it's also got the tenths marked off. So I know for sure, like this line was 20. This line here was 20.1 milliliters. We definitely delivered 20.1 milliliters. We definitely did not deliver 20.2 milliliters. So I can say 20.1, and I still get one more spot as an estimate. So maybe I guess 20.15 milliliters. That's my estimate. And again, I don't care what it is as long as it's reasonable and it's there. As if your buddy said 20.14, 20.16. I can live with it. That is fine. But it's very important to take that estimate. That'll affect how we can use this in calculations. And it also kind of tells us the precision of the measuring tool that we were using. So very important to remember. Burettes read volume delivered. So they're kind of backwards.